All right, we're recording, so good morning. Today is Wednesday, the 31st. I sent out an email this morning, pretty much showing you what we're going to be doing today. Let me just say this to you. There are now 11 people in the class. One person has dropped. And out of those 11 people, 9 took the test, 2 did not for whatever reason. And the 9 who took the test, everybody got 100%. All right, so I am going to review it because there's a couple things I'd like to say about it, but not too much. So everybody who's still registered for the class should have gotten an email from me yesterday that had a copy of the test in it and your grade. So I'm going to start today by reviewing the test as it says. Then we're going to go over chapter 5. I'm going to do this a little bit differently in that as we go through how to use if statements and switch statements and looping, I'm right now, all I've created is an empty console app, and I'm going to be working in there. So I'll do something, I'll get it to work, then I will comment it out so I can go on and do something else. And I'm going to go in and create a Git repository for this. And then I'll take everything that I've done and I will put it out on the Git repository. All right, we'll do that in conjunction with working with chapter 5. At the end of chapter 5, I'm going to go over that payroll example that we did yesterday, but I'm going to add some stuff to it that will, for lack of better words, force us to use some of the material we're going to be using in chapter 5. All right. And we'll see where we are time-wise when we get done with that. This afternoon, I will email you the pre-test for chapters 4 and 5. All right. And what I'm going to do, both of the problems that are on the pre-test will be console applications. All right. And what I will do is I will give you till about, I don't know, 9:30, 9:35 tomorrow, an hour and a half to work on this. And then I will do the pre-test right in front of your very eyes. All right. And I imagine it'll take hour and a half. I don't really know, but that should take us till around 11 o'clock. And then at that time, what we will do is we'll take a quick look at the homework and the labs for chapters 4 and 5. All right. And maybe even do a problem or two. We'll see. So that's, like I said, that's what we have on tap, so to speak, for today. So let me immediately go in and change my share. And I'm going to bring up let's see. There it is. There's the hands-on test. So you should see on your screen right now a copy of the hands-on test. All right. And there's just a couple things that I wanted to mention about it. All right. And again, what I'm going to do, I don't know when, but if nothing else, I'll do it next Tuesday when you take your test. I want to show you one more time how you should be creating these, how you should be saving these, how you should be pushing them to GitHub. You should have one solution in your HOTS folder where you're going to put every single hot, everything. Some people created their first test. They have 3 solutions. That's not the way you're supposed to do this. So I'm going to run over it yet one more time, but not today. All right. Everybody seemed to have, this, you could have done this a lot of different ways. But really what you should have done, and not everybody did this, it said that asks your name. So really what you should have done there is you should have done something like, and I'm going to remove this afterwards, but you should have said like string first name equal, and then you could have said something like write console dot write line. In fact, we would have wanted to do that up here, so let me move that up. So you would have said, like, enter first name, something like that. All right. Then you would have said string first name equals console dot read line. Then you would have done the exact same thing. So let me copy this, but you would have said enter last name. And then you would have said string last name equals console.readline. Then all you would have needed to do was to say console.writeLine. And in fact, this is good because I didn't do this right. You really should be doing this, console.write. Almost all of you did a console.writeLine. You should be putting your input on the same line as the statement that asks for the input. So now you would use a write line and just say, hello, comma, plus first name, plus a blank space, plus last name, something like that. And basically, if you did that, and you'd probably have to put a console.read line afterwards just so it didn't fly off the screen. That's all we were looking for that first question. That was it. All right. So that was the first one. Number two. Again, I don't mean to be picky, but I am going to be picky. And what I'm saying is, notice what this says. Asks for any three real numbers. I mentioned in class that a real number is a number with a decimal point. So you should have made that either, you should have made three variables, and the variables should have been of type double or of type decimal. A couple of you one person made 5 variables and one made 4. I'm not, like I said, I guess I'm being picky here, but follow the requirements. I'm not saying you have to look at these requirements and agree with them, but you should be following them. All right. Okay. So basically you would have read in 3 numbers. Now, some of you did this. Some of you went in and did stuff like this. You said decimal, gotta be a little d. And then you said like number 1, something like that. No, start your variables with lowercase, always. That's just the standard for doing things. So you would have had to have read in the value of all 3 of those. And then some people did something like this. They said decimal, total, equal, and then they said like, and number 1 plus number 2 plus number 3. And then they said, basically like decimal, AVG equals total divided by 3 or 3.0. That's fine. You could have also come in here and just not even had a total and just done, done it like that. That would have been fine as well. And many people did it that way. You really don't even need the 3.0 here because these are already decimal values, but it doesn't hurt to put it in. All right. And finally, on this last one. Now, I mean, let's be picky here. Technically, it's saying here, what is your name? It's not asking for your first name and your last name. It's just asking for your name. Many people really just used one variable there, and that's actually what you should have done. If you used 2, I didn't take off for it. All right, but you just asked for your name, and it's showing it there as one variable. So that should have, this should have been basically right here, a write line, enter your name, and then you read in this. Then, street address, and you enter this, city, and you enter this, state, etc. All of these that are over here should have been write statements, not write lines. All right, many of you used the right line there, and then this where you enter the John Doe, it was on the next line. That just looks poor. I want you to start doing things the right way. All right. And you'll then do this. Now, a lot of you had this done, but you didn't really format it at all. That's okay. All right. As we go on in here and we write more and more complex programs and you learn more and more, the requirements are going to get stiffer, for lack of better words. All right. And when you're told to do something, it's going to be expected that you're going to do it. All right. Okay. So I'm going to go on unless there's any questions on that. I'm just going to go on right now and I'm going to change my share and start going into chapter 5. Like I said, overall, I was just fine. People did just fine on the test. So we have now, this is our table of contents. We've already done chapters 1, 2, and 3, and we've tested on them. Yesterday, we went through chapter 4. All right. How to work with numeric and string data. Today, we're going to go over chapter 5, how to code control structures. It's about 10 pages shorter than the last chapter. All right. And again, I will be stopping at various points, changing my share, going into Visual Studio, and actually working with a console app that I've created. I could do this with a GUI, but I want to do it with a console because I really want to concentrate on the code in this chapter. This is the first chapter that's really, for lack of better words, code intensive. All right. So, whoops, let me jump back. Sorry about that. That was the wrong one to put in there. We want to go to chapter 5. So page 133. All right. So it says, now you'll learn how to code the 3 types of control structures common to most programming languages: selection, case, and iteration. Now, the selection, basically, those will be different versions of an if statement. The case will be literally a switch statement. And the iteration, there's 3 kinds of loops that you can do in here. You will not be forced on your next test, like you won't be given a problem and say, you must use this loop. It's up to you typically to choose the type of loop that you want to choose. All right. So you can see that this is broken down into 1, 2, 3, 4 different sections. The first one will talk about Boolean expressions. Again, Boolean means true or false. All right. And we will talk about the relational operators and the logical operators, and I'll show you examples of each. Then we'll go into how to code conditional statements and expressions. I will write some fairly simplistic code and I will use an if statement. Then I'll make it an if else statement. Then I'll make it an if else statement. Then we will go back and write the same code as a switch statement. All right. Then I will go over with you the conditional operator. And you'll notice there's an enhanced version of the invoice total application. So we'll look at that. Hopefully, at least, we can get pretty much most of that done by the break. Then after the break, we'll talk about the 3 types of loops. Those are the while loop, the for loop, and the do while loop. We'll also talk about with loops how you use the break statement and the continue statement. And again, I'll show you examples of each one. Finally, we'll go and we'll look at a new application, the future value application. And Aiden, you are the only one on right now, but as always, if you have questions, please don't hesitate to ask. All right. So it says when you code an expression that evaluates to true or false, that's a Boolean expression. Okay. So it says you need to learn how to code Boolean expressions before you can learn to code control structures. So when you work with Boolean expressions, all right, one of the things you typically use are relational operators, and they're shown right here. Now I'm going to quickly, in just a minute, I'm going to change my share, and I'm going to quickly write something where you can see an example of each one of these. Before we do that, if we look quickly at these, you might say, oh, geez, I learned these back in junior high. I get it. When you're checking for equality, you must use two equal signs. When you use one equal sign, when you use one, it's doing an assignment statement like x equals 6, which means assign the value of 6 to x. When you use two equal statements, you are checking for the truth or false of something. Inequality then is an exclamation point followed by an equal sign. Greater than, less than, greater than or equal to, and less than or equal to. Hopefully, at least, those just make sense. So let's change the share here and take a look at a couple simple examples. I don't want to waste a lot of time on this. All right. But again, I also don't want to assume that, oh yeah, everybody gets this. There's no problem with it. You never know. All right. So there's Visual Studio. So here I am. Hopefully you can see my Visual Studio screen up right now. All right. And I've got nothing in here. So I'm going to create two variables. So I'm going to have an integer and I'm going to use x and y. So x is going to be equal to 17 and int y is going to be equal to 12. There's nothing special about those numbers. All right. So I'm just going to do all those things that we just looked at. I'm going to say here, whoops, not like that. If x is equal to y, then I'm going to say console.writeLine x equals y. Well, you are all smart people. You all know that's not equal to y. So when I run this, if I do a file and I do a save all, and let me put at the end of this, let me put a console.readline so it doesn't flip off the screen. Okay. So if I save this now and run it, basically nothing's going to happen. It just sits there and I can hit enter and I'm done. Now I can add onto this and I can say else, and I can do another console.writeLine. And I can say x does not equal y. Well, again, the key takeaway from this is when I do a Boolean condition with an if else, if it's true, you do this, and then you skip the else. If it's false, you must do this. I mean, I can't make it any simpler than that. All right. So if I do a file and I do a save all here and I run the program, it comes up and it says x does not equal y. All right. So I'm going to take all of this code that I just put in here and I'm going to comment it out. In fact, I'm going to copy it first. Then I'm going to comment it out. Then I'm going to come down and I'm going to paste it in again. But now I'm going to check and say if x does not equal y. All right. So now I'm going to say if x does not equal y, write out x does not equal y. Well, they don't equal, so that actually this should run, which means again, this gets skipped. All right. So let's see if that's the case. And it says x does not equal y, exactly what I want. All right. Again, I realize these are a little bit contrived, etc., but I just want to run over every one of them. And the reason is not so much for the people who are watching live here, but I want to make sure everybody gets this. If x is greater than y, all right, oops. So is x greater than y? Yes, it is. So what should print here is x is greater than y. So let's see. and it says X is greater than Y. All right. If I do it again, and I'm just going to change this to greater than or equal to. So I'm going to say X is greater than or equal to Y. All right. And I run the program again. And it says X is greater than or equal to Y. All right. So finally, doing the last two, if I say X is less than Y, so this would be less than, all right, is not less than. Well, it isn't, so this else should be hit because 17 is not less than 12. So this line should be skipped. And since it's an if else, there's that one. That should say X is not less than Y. And if I run it, you'll see, sure enough, X is not less than Y. And then finally, the last one, would be less than or equal to Y. And run it again. And it's not less than or equal to. Now, that was quick. I get it. We just spent literally 5 minutes doing that. All right, I'm going to comment this one out right away because we're going to go back to our book and go on, and then we'll write more code in here. So if you wanted to test any of these, anybody who had problems, you could uncomment any of these. Remember, you highlight it, and to comment it out, it's this one that's right here. To uncomment, it's the one right next to it. All right, so they're toggles, they get turned on and off. So that's the relational operators. It's the relationship between what's on the left of the operator and what's on the right of the operator. All right, so let me go back here and change back to Google Chrome. All right, so I'm not going to say anymore. I'm not going to read these or anything else. All right, then there's logical operators. There are 3 of them. There is the double ampersand, which is and. There is the double pipe sign. Looks like 2 sticks or something like that. That's or. And there's the exclamation point, and that's not. Before I go over this, because I want to talk too about short circuit operators, let's look at their examples. All right. Now, when you do and, what's to the left of the and must be true, and what's to the right of the and must be true. So both things, so there's 2 conditions in here. So for this to be true, the subtotal must be greater than or equal to 250, and it must be less than 500. So in other words, in that example, the subtotal must be between, it must be between 250, all right? It must be between 250 and 499.99. Now, when you do an and like this, let's pretend for a minute we had a value for subtotal, and the value was 0. All right, 0, you know this as well as I do, 0 is not greater than or equal to 250. So when you use the double ampersand like that for and, if the first half, what's to the left of the ampersand, if that is false, you never check what's on the right. You don't have to. Since they both have to be true, if you already found one was false, why should you check the other one? That's called short circuiting. It's a short circuiting operator. So when you use the and, if the first condition in your and is false, you don't check the second condition. With the or, it's either one or both must be true. So with an or, if the first one is true, you skip the second one because you don't have to check it out. If you want to force, no matter what, I want you to check both sides regardless. then instead of using 2 ampersands, you use 1, or instead of using 2 pipe signs, you use 1. All right? And not is the inverter. Not reverses the value. So if you say not for something and it was true, it becomes false. If you say not for something and it was false, it becomes true. All right? So those are them, basically. Okay? So before we go into the if else, let's jump back for a second. So I'm going to jump back into my Visual Studio Code, and we're going to look at those. All right? So remember this, I'm going to copy this down so you can see it, and I'm going to just comment it out, but we're way down here now. So let me paste that in. All right, and I'm going to immediately comment these out because I'm just putting them in there for clarity so you remember that. So I can come in here and do this. If I come in, I can say if X is greater than or equal to 20 and Y is less than or equal to 100. All right, I'm not even going to do anything here. I'm just going to put that condition in there. Now let's look at that. Is X greater than or equal to 20? No. I'm sorry. Yes, it is, right? Because, no, it's not. Because 17 is not greater than or equal to 20. Since this is false, and since I'm using this will not be hit. Just to prove that, I'll do a console.writeLine, and I'll just say condition true. All right. And then I'm going to come in here and put an else in here, and it's going to say condition false. So again, when you are running and you are doing an and condition, both what's on the left of the and what's on the right of the and must be true. We have one that's false, so this should come back and say condition false. So file, save all, run it, and it says condition false. If I do that again, all right, and I'm gonna, like I said, I'm gonna just keep copying this stuff. All right, so if I run this again, and I change it to 10, all right, now 17 is greater than or equal to 10, and 12 is less than or equal to 100. Now it should print in here, condition true. Let's see if that's the case. And it says condition true. All right. I'm not going to do an example with just 1 ampersand. We could, all right, but all that does is it forces that stuff to happen. Now, let's go in and use the same examples that we just had. So let me copy all of this. All right, I'm going to take what's in here and I'm going to comment it out. Now I'm going to come down to here and paste all that in. I think I did not paste in the last curly brace. All right, and now we're going to change these. So let me comment this out first. And let me uncomment this. So now we're going to change this to an or. All right. Now, if we do this and we come in here and we say if X is greater than or equal to 20, it's not. So we must check this. We must. But since the second half of that is true, it should come back and say condition true. So let's double check to make sure that indeed happens. And it says condition true. Perfect. On the other hand, if I had made this a 10, it's still, oops, if I had made this a 10, it's still going to say condition true, but it will not check that side because it doesn't have to. So even if I change this to greater than or equal to 100, which it's not, but it's still going to come back in here and say true. Okay, so let's put that back there to that. All right, and we said at first when we did this, we can say greater than or equal to 10, or, well, we can make this one less than or equal to 10, which is false. But since this is true, it should again come back and say true. And it does. It says condition true. All right. And then quickly going over this last one. So let me comment this out. And actually, I guess we just did. So let's talk about the not, which is the inverter. Okay. Now, if I do this, I'm going to just go back and take the one I just put in here, this one. Okay. Let's do this first with an and let's make both sides of this true on purpose. So I'm going to uncomment this. All right, so if X is greater than or equal to 10, all right, and Y is less than or equal to 100. You already saw this, okay? But when I come in here and I do a file save all and I run it, it sure as heck should say condition true, and it does. But if I come through here, all right, and what I put in front of this is an exclamation point, all right, that's an inverter. So it now says condition false. That took my true condition here and it said, give me the opposite of it. All right. So in other words, it took what was true and it made it false. All right. So let me grab this one last time because we're almost done with this. And again, if I'm boring you, I guess I apologize in advance. But some people get logic and some people have a problem with logic. If I make that an or, is that true? Yes. Is that true? Yes. But since I'm using the not with it, you'll again notice it says condition true. Well, why is that? Because it really ran that on here. All right. So let me do this. I'm going to put another paren here and another paren here. So is X greater than or equal to 10? This whole thing right here, this is true. But since I'm inverting it, it should come back and say false when I run this. And it does. Now that was a lot. It was a lot more time than I'd planned on spending on that. But again, using if statements, which is what we're just starting to do right now. All right. But using if statements are so central to programming, it's pretty much incredible. So I'm going to leave all that in there, but I'm just going to comment it all out. Now I'm going to add two more variables. I'm going to add int num1, and I'm not going to give it a value. And I'm going to say int num2, and I'm not going to give it a value. All right. And why am I doing that? You're going to see it in just a minute, but I'm going to have to go back. Let me do a file save all here. And let me go back in my share. Let me go back into your book. Now, it may end up that this lecture takes a little longer than I thought, but again, this is such an important topic, talking about ifs, if else, if, etc., and switch and the loops. I'd rather spend a little more time on it, all right, and make sure that people have an understanding. So those of you who are watching this, not live, but the rest of you who are watching this on tape, if you have questions, you must ask me. All right. All right. So now we're going to talk about ifs in more depth. Now, I don't like the way this one is written. If there's only one statement after the if, you don't need curly braces. I always use curly braces. So I would not write mine the way that this one is written and the way this one is written. It's not that you can't. I just wouldn't do it. All right. So you can have an if, you can have an else, you can have an if by itself, and if with an else. So when you got an if by itself, if this is true, you'll do this. If this is false, you'll do nothing. With an if and an else, if this is true, you'll do this. Otherwise, you'll do this. And if and one or more else ifs means do this one. If it's true, skip everything else. If it's not, look at this one. If it's true, do that and skip everything else. If not, go down and do this one. If that's true, do that one. If it's not true, go down to this. Now, this is very, very, very similar to the problem that I went over with you with that grade thing. All right, where we had the grades, if it was greater than or equal to this, etc. Now, when you've got ifs with else ifs, it is not mandatory that you put a final else in there. It is not mandatory that you do that. However, most people do. Finally, you can have what are called nested ifs, which is an if inside of an if. Now, you will only get into this code right here. You will only get into that code in the gray, only if this is true, right here. If that's true, you'll go in and do this. If this is false, you'll skip all that and you'll do this. That's called a nested if because it's an if within an if. So let's take a quick look here, okay, at an example. And I probably wouldn't have even needed two variables. I think I can just use one, but I'll leave them both there. So I'm going to do this. I'm going to do a console.write, and I'm going to say enter a number. All right. And then I'm going to do a console. Whoops, I'm sorry. I'm going to say that num1, that was the thing I did up above, equals convert dot toInt 32 readline, console.readline. All right. Then I'm going to say if num1 modulo 2 equals 0. Let me get the whole thing out and then I'll go over it with you. If that's true, console.writeLine, the number is even. Else, in fact, let's not write anything. So if modulo 2 equals 0, we're going to write the numbers even. Okay, so let's run this twice. Let's run it the first time. So I'm going to do a file, save all, and I'm going to run this. And it comes back and it says enter a number. And I'm going to put in here 12, which is an even number. So it says the number is even. Good. I'm going to run it again. And it asks for a number. And I'm going to put in 13. And nothing happens. Why? Because I told it to do nothing. So let's put an else in here. And we'll say else, and I'm just going to steal this statement. And I'm going to say the number is odd. So now with that in there, if I do a file, save all, and I run the program again, and I say 12, the number is even. Okay. But if I run it again and I say 13, now it says the number is odd. All right. So that's fine. But I want to do one more thing. 0 technically is not considered to be even, and it's not considered to be odd. So I'm going to change this to say if, no, whoops, I can't do it there.
I don't think I can see the.
All right, then we'll go back. Is it back?
Yeah.
Okay. So I'm going to come back in here, and after I read it, I'm going to put in an if that says if num1 equal 0. So if it is equal to 0, then I'm going to say console.writeLine 0 is neither odd nor even. And I'm going to change that to an else if. So now I'm going to read in a number. If the number is 0, I'm going to print that and I'm going to skip all this. If the number is not 0, I'm going to divide it by 2 and check the remainder. All right. And if the remainder is even, in other words, there is no remainder, I'm going to say the number is even. Otherwise, I'm going to say the number is odd. So I'm going to save this and run it 3 times. I'm going to run it first and I'm going to put a 0 in there. 0 is neither odd nor even. That's good. That's what we wanted. I'm going to run it again and I'm going to put in 312. And it says the number is even, which it is. I'll run it one more time and put in 569. And it says the number is odd, which again, it is. So that is basically a demonstration of how you use if by itself, how you use if with an else if, and how you use if and an else. If there's only 2 possibilities, you want an if and an else. If there's multiple possibilities, you want to do something like this. All right. I'm going to give you one more example because it's going to lead into what we're doing next. So I'm going to copy this and comment it out. And I'm going to add a new variable up here that's going to be called size. So string size, I'm just going to set it equal to the empty string, which means it's equal to nothing. So I'm going to come down here and I'm going to let's see, I'm going to steal that code from here, set write a number. All right. But I'm going to come down here. Don't worry about those errors. Any errors are going to go away. I'm going to say here, enter your size. All right. And I'm going to say size equal, I don't need to do any convert, just a console.readline because it's already a string. All right. If size is equal to S, all right, I'm going to say you're a small. All right. And I'm just going to steal all this. Else, if size is equal to an M, all right, we're going to do a console.writeLine that says you're a medium. We're going to just suppose there's 3 sizes. All right. So I'm going to leave that last else in there and I'm going to copy this one down. Otherwise, if it's an L, I'm going to say you're a large. All right. Otherwise, I'm going to say unknown size. Okay. So I'm going to ask you to enter a size, and you can even tell the person you should put in an S or an M or an L. I mean, you could try to help the person as much as possible. All right. Sometimes they'll still do it wrong, but that's okay. So I'm going to save this and I'm going to run it a few times. So we run it. We put in there for our size. We put in an S. You're a small. Good. That's exactly what it should do. We run it again. We put it in M and it says you're a medium. Good. We run it again. We put it in L and it says you're a large. That's all good. All right. We run it again. We put in a Z and it says unknown size, like it should. The problem is right now, all right, if we run this and we put in a lowercase s, not an uppercase, it says unknown size. So how do we fix that? This is jumping ahead a little bit, but it says here size equal console.readline. But I'm going to come down on the next line and I'm going to say size equals size dot to upper. That takes whatever input I put in here and it puts it into uppercase. So if I put a lowercase s in there, it'll become an uppercase S. All right, so I'm going to save that. I'm going to run it again, and I'm going to put a lowercase m in there, and it says you're a medium. Good, so that's now working. So why did I take some time to show you this? Because I want to go back and I want to rewrite this. All right, so I'm going to keep this, all this, I'm going to take all of this that's here. I'm going to copy it to the clipboard. Then I'm going to comment it out, paste it right back in. Why? Because I want to rewrite this. I want to rewrite this, and I want to use what's called a switch statement. So I'm going to do a switch on size. All right. And this, it's going to give me a bunch of errors. Don't worry about it. We'll get it all fixed in a second. I'm going to remove all of this. I need my console dot write line down, read line down there. Let me just copy this a bunch of times. Small, medium, large, unknown size. Okay, this will all be fixed in about 1 minute. All right, so this will be M, this will be L, and this will be the word default. This says you're a small, this will say you're a medium, this will say you're a large, and this will say unknown size, exactly like it did before. So when you have a limited number of things you're checking and their exact values like this, a switch can be a little bit easier on the eyes than this series of ifs, else ifs, and else statements were. You may not agree with that, which is totally fine. All right. Or you may agree with that, which is totally fine. All right. But this switch says, okay, now I've got a variable called size that I just uppercased. So I'm going to do a switch on that. All right. What if I forgot to do this? If I didn't do size equal size dot to upper, well, then it wouldn't work when I put in a small s. In fact, I'm going to take it out. But I'm going to say this, case small s, case small m, case small l. All right, now it'll work. So I've just quickly shown you two different ways that you can work with selection by using either if statements by themselves, and if with an else, and if with one or more else ifs, and if with one or more else ifs with an else, or doing it using a switch. So just to show you, when I do a file, save all, and I run the program again, if I put in a lowercase s, still says you're a small. If I put in a lowercase m, still says you're a medium. If I put in a lowercase l, still says you're a large. And if I run it and put in something that makes no sense, it says unknown size. So all that stuff works now. All right. I'm going to give you a break in about 5 minutes. We'll take one right at 9 o'clock. But let me jump back into the book. So I have now discussed the if statement. And again, we have also gone through and looked at the switch statement. I thought it would be better, rather than showing you what's in the book like this, I thought it would be better to actually just show you a working example. So what I did was I took an if statement with else ifs and a final else, and I changed it to a switch statement. All right, so I showed you how to code the switch statement. Now, 2 or 3 more things before we go in and take a break. All right. And I've got to switch back, but it's kind of important. So that's why I want to do this. Hopefully you can see my Visual Studio window again. You need the word break in here. If I left off this break and this break and this break, if I left off those three and I put in S, it would print this, it would run down and print this, it would print this, and if there was no break there, it would also print this. Break means get the heck out of this switch statement. So as soon as I put in lowercase or uppercase s, it prints this and it gets out of the switch. All right. That's one thing to realize. The second thing is it's not mandatory that you put a default in there, but that's your final else. That's saying, hey, if nothing else was true, I want to do this. So normally, good programming practices say that normally you will put in a default statement, even though, again, it is not mandatory. Now, I'm jumping back again. Sorry about that. But there have been some changes that have been added to the way you write these. All right. You can now use, I think this is called a discard. We'll see it just a minute. Let's see. What is it? It's a lambda. Yeah, it's the discard. That's the underscore. This is this is another way that you can write these statements. The good news is that you write less code. The bad news is it's pretty hard to understand when you're just learning. I would recommend for right now that you read this page, and if you have questions that you ask the instructor, but I would recommend you don't use this. It's just, like I said, it's just more complexity than you really don't need right now. If you don't agree and you want to try using that, totally fine. All right. Last thing before we take a break is the conditional operator. It's a shortcut operator, and I'm going to show you that, then we're taking a break. So I'm going to jump back into Visual Studio because I think this is the easier way to show this to you. All right. And I'm going to come back here. And I had, if you remember from before, we had X, Y, we had num1. I'm going to get rid of this num2 because we've never used it, but I'm going to have another variable I'm going to call max. All right. And max is going to be the bigger one of these two numbers. Okay. So you've seen this kind of thing before. You have, whether you think you have or not, but I want it to make some sense to you. So I'm going to do this. I'm going to say if X is greater than or equal to Y, console dot right line, X is bigger. So X is the biggest. All right, even if they're equal, I'm going to say that anyway. And I'm going to say else. And I'm going to do another console.write line, but it'll say Y is the biggest. All right, you already know, or hopefully you do, what's going to happen when I run this. It's going to come in here and it says X is the biggest. That's exactly what I want. All right, if I flip these around and I put here Y and I put here X, all right, it's still going to say X is the biggest. No, it says now Y is the biggest. Why does it say that? So if Y is greater than or equal to X, okay, it does this one because it's not. All right, but what I want to show you is this. If I came through here and did this, if I said X is greater than or equal to Y, all right, if it's greater than or equal to Y, rather than saying this, X is the biggest, Y is the biggest, I'm going to come in here and say max equals X. I'm going to say else max equals Y. Then down here, I'm going to write out console dot write line, and I'm going to say max equals, and I'm going to put in here plus max dot toString. All right, sorry, it's 9, but I just want to do this and finish this part of it up. All right. Well, 17 is greater than 12, so it should set max to X, and it should come down here and say max equals 17. All right, should say that. And it says max equals 17. That's exactly what we wanted. So what did that prove? I want to show you how to write this in one line. All right, so I'm going to comment that out, and I'm going to rewrite it like this. I'm going to say max equals, and I'm going to check X greater than or equal to Y question mark X colon Y. That did the same thing. What this does, it's called the ternary operator because there's 1, 2, 3 operands in here. It says make this check. That's what's in the parentheses. If the check is true, do what comes after the question mark. If the test check here is false, do what comes after the colon. Since it's true, it should take X and assign it to max. So it should still say max equals 17. So let's run it, make sure. And it says max equals 17. All right. So I could come in and add one more variable, and I'm going to say int min for the smallest one. And I'm going to grab that same test. I'm going to grab these two lines. And now I'm going to come in here and say min equals if X is less than or equal to Y, set X to min, otherwise set Y to min. Then I'm going to print out here min equals, and that'll say min. All right, save that, run it, and it says max equals 17, min equals 12. Exactly what we'd want. Sorry, it is 9:02. I'm going to give you a little longer break for that. Let's come back at 9:15 in 13 minutes. We're going to pick it up. I'm going to change my share. I'm going to go back to the book. And we just went over the ternary or conditional operator. All right. So I'm going to be looking at this enhanced version of the invoice total application. I'll be back at 9:15. All right, it's 9:15 and I am back. I'm not sure where I left the share off of, so I'm going to try to reset it for a minute at least to our book. So the next thing that was discussed in here was an enhanced version of the invoice total application. So what they did was, notice they've added a customer type in here that's R. All right. And what they've done is, if the customer type is an R or a C, they are giving you different types of discounts. All right. So I'm not going to do that right now, but we will do that by the end of the class. All right. I'll go and bring this back up again. We can add that. In fact, technically, we don't even really have to, because you're going to see this in other things that we do. But let's go over the code that's shown here. All right. So we've got this customer type, and that's what you put in the text box. If that type is an R, and again, they should have done a 2-upper on that, because if you put in a lowercase r, it will not handle it correctly. But if your type is an R, then you look at the subtotal. If it's less than 100, you get no discount. If it's between 100 and 250, not including 250, you get a 10% discount. And if it's greater than 250, you get a 25% discount. So that's handling everything right there. That's handling everything for a customer type of R. Then for C, you always get at least a 20% discount. So if it's less than 200, you get a 20% discount. Otherwise, you get a 30% discount. For anybody who's not an R or a C, you get a 40% discount. Now, why they did it like this, I don't know, but that's just a way that they set it up. All right. So, I'll tell you what, let's do this. So let me start up another session of Visual Studio here. And I'm looking through my mess. It looks like, of course not, I've got to find that. So let me find quickly my enhanced version of the invoice total program. Okay, just give me a second here, and I think I know right where it is, but we'll find out. There it is. So I'm going to copy it there, and I'm going to bring it up. All right, this will necessitate me changing my share again, but I want to wait until it comes up and hopefully looks okay. All right. All right. So let me change my share again. Oops, not that. Let me change my share again here. All right. Hopefully, and you can see on the screen right now, the background is orange, and it has got all the information in there for the subtotal, etc. It's got all that stuff in there. All right. So the first thing I want to do is I want to unlock my interface. Why? Because I want to move this all down just a little bit. So I'm going to highlight everything here and move it down so I can add one more thing up here. All right. And this will be the customer type. So I'm going to put that in right here. First, let me go in and relock my interface. All right. So this will say enter customer type. So this will be LBL customer type. So LBL customer type. And I will put in there, I won't even say enter, I'll just say customer type, like that. Well, we can say enter, I guess there's enough room for it. In fact, we'll do this, enter Yeah, we'll just leave it like that, customer type. That looks okay. All right, and this will become TXT customer type. Right? So we've now got both those done. There's no code for this, so that's not going to help any. All right. Now, what we had done before, if you remember in here, is we had set up a constant of a discount percent of 25%. I'm just going to comment that out. All right. And I'm going to come in here, so that discount amount is going to change. So don't worry about that. We'll just comment that line out too. All right. And yeah, I'm going to have to comment out everything, unfortunately, but just let me do that. But we'll fix it right now. So the first thing I'm going to do is I'm going to say string, and I'm going to say customer type, and I'm going to set that equal to txt customer type dot text. So whatever we put in there. Okay. All right. Then I'm going to come down here and I'm going to just put in some code. Normally I wouldn't do it like this, but I'm trying not to have to rewrite too much stuff. So I'm just going to keep it simple. I'm going to say if customer type equal. So if it's equal to R, I'm just going to give you a flat, your discount amount is going to be equal to a flat 30%. So 0.3M. All right. Oh, I don't want to do that. I just want to say, do I have a discount amount? And that's over here. So I'm going to say here, decimal discount amount, and I'm going to set it equal to 0M to start with. All right, you'll see exactly what we're doing in a minute. All right, so this will now say discount amount is 0.3M. Okay, and I spelled amount wrong. All right, so again, if the customer type is R, the discount amount is equal to that. Else, if the customer type equal C, then we're going to set the discount amount to 40%. Okay. Otherwise, we're going to set the discount amount to 10%. Right? So now all that stuff should be set. So I'm going to come in here and I'm going to look at the customer type, and I should do a .2 upper on this. So it'll handle either uppercase or lowercase r. So it'll handle either uppercase or lowercase c. So a person comes in here with an R, they get 30%. With a C, they get 40%. If nothing or anything else, they get 10%. All right. Now I only have to make one more change in here. This has got to change to say the discount amount equals. So that is I need another thing called discount percent. Set that equal to 0M. And that's what we're going to set on all these, the discount percent. So the discount amount now is just going to be equal to the subtotal times that discount percent. Right? So this should now be okay. This should now be okay. So should this. So should this. So that was a comment. So let's quickly go over this. I'm not trying to waste my time. I'm not trying to waste your time. All right. But we'll go over this and then we'll make one little add to it. So this is our new discount amount right here. I want to actually set it down here. So I'm just giving it a value to start with of nothing, of 0. The discount percent I'm also setting down here. So I set that equal to 0 as well. All right. And then we come in here and we make our check. Well, I can line these up if I'm going to be a little ADD about this. Oops. All right. So I've come in here now, and I can actually come in and also say decimal total. And again, set that equal to 0M as well. Total. And then down here where I've got total, I can just say total equals. What I'm trying to show you here is the way typically you would write the program. All right, you would declare all of your variables up here. And if you didn't know their value when you started, all right, if you didn't know that value, you would just initialize it to 0 or the empty string if it was a string. Now, let's run this and first of all, and see if it works. So I'm going to come in here and I'm going to make the customer type an R, and I'm going to make their subtotal to be $100. So at $100, they should get a 30% discount, which means their discount amount should be $30, which means their total should be $70. Okay, then we'll run it again and we'll put a C in there and $100, and their discount amount should be $40, and their total should be 60. Finally, we'll run it again and I'll leave it blank, and they should get a 10% discount. So let's see if all that works. There were build errors. Now what's the error? Oh, there we go. So that is discount percent. That's what that is. ToString P. So what doesn't it like here? Didn't we have a discount percent? Up here, discount percent. Doesn't it like? It says does not exist in the current format. Okay, the reason that it doesn't exist is we declared it. We declared discount percent in here. Okay, so I'm going to remove it and declare it up here, making it global to the programmer, making it a class level variable. Now that error goes away. All right, now I can run it. So let's look. Now I'm going to put in an R here again, and I'm going to put in 100 right here. That should set my subtotal, all right, to 100. It should set my percentage, discount percent to 30, my discount amount to $30, and my total to 70. And you can see that it does. All right, so that one worked. Let's clear it and do it again. Now we'll put in, I should clear that out too, but I didn't. I'll change that. I'm going to make it a C, and I'm going to put in here 200. They should get a 40% discount. So this should be 200. That should be 40. That should be 80. And that should be 120. And it worked. All right, so now it's all working. One thing I want to do is I want to come up where I'm clearing, and I want to say txt customer type dot text, again, equals double quote, like I've been doing. And now I can set the focus to txt customer type. All right. So that's all done. I want to do one more thing, and that's similar to what they did in the book. And let's say that here, if you bought a lot of stuff, here, if you bought a lot of stuff, you get a 50% discount. Otherwise, your discount is 30%. So I'm going to say here, if subtotal is greater than or equal to 1,000, so if you bought $1,000 or more, then your discount percent is equal to 50% or 0.5 M. Otherwise, it's 30%. We'll just change that one. We could change the other one as well, but that should be enough. So I'm going to run it one more time. I'm going to put R in there, but I'm going to put $1,000 in. So 1,000 should be my subtotal. At 50%, I should save $500. So let's see if that works. So again, I come in here, 1,000. So that should be 1,000. That should be, whoops, it's the customer type, I'm sorry, with 1,000. So that should be 1,000. That should be 50%. That should be 500, and so should that. And you can see it works, except it didn't set the discount percent. We'll fix that right now. All right. It says here discount percent equals 50, so why wouldn't it have taken that? Customer type is an R. Percent should be 50%. Let's run it again and make sure. So R 1,000. That's working, but if for some reason it's not setting that, I'll have to look at that. But it is working. The other thing I should do is I should take whatever is going to show here and I should uppercase it just because it'll look a little bit nicer. So let's stop this. What doesn't it like here? If the subtotal is greater than or equal to 100, the discount percent is 50%, 0.3 M. Discount amount. I can actually come in here too, and I could really set the discount percent right here. That's what the problem is. That sets it at the beginning. I want to set it throughout the program. So now I can say this, that the percentage is now set. So let's run it one more time. R 1,000. Now it says 50 and you save that and there you go. If I do it again, 2,000. All right, that should be 2,000. That should still be 50. That should be 1,000 and so should that. So it's working. If I put nothing in here, all right, you can see that they get a 10% discount. And if I put a C in there, they get a 40% discount. So it all at least appears to be working. I will push this one out to GitHub in just a couple moments. All right. So let's see. The only thing I wanted to say was when we get all done, the other thing we want to say is txt customer type dot text equals customer type dot to upper. That shouldn't hurt anything if we leave it blank. Okay, but if we put a lowercase r in here, it's now an uppercase R. And if we put a lowercase c in here, it's now an uppercase C. Just a little bit more professional looking. You may agree with that. You may not agree. All right, totally fine either way. All right, so there's that one, and I'll have to make sure that I push that out there later. I don't want to take the time to do that now. So instead, what I'm going to do is I'm going to change my share here. And I'm going to go back to our textbook. All right, I think I gave you as much as they have in here on that thing, but you know, I want to go into loops because that's the last thing in this chapter that's really discussed. All right, I always show loops in a different way than they do in the book. So I'm going to show you my take on loops. And after I get done, I'll go back and go through everything that's in the book. All right, because I like to show them to you in what I consider to be a pretty darn simple way. All right, so I'm going to stop that run and bring back up this. Okay, I've got to change my share so you can see my Visual Studio here. All right, what you should see then is what we just did with that conditional operator. So I'm going to comment this out. And as goofy as it sounds, I'm going to write 3 programs that are just going to print out the numbers from 1 to 10. All right, now I could do it the worst way possible. And that is, I could have, for example, I could put in, if I wanted to meet you on another line or whatever, I could probably just do it as one write line. That wouldn't be too bad. All right, I could do it as 10 different write lines. That's a little more work. But imagine I wanted to print out the numbers from 1 to 100. That'd be a lot more work. So we're going to be introduced to loops right now, and we're going to start with the while loop. All right, so I'm going to say here, int LCV equals 0. Don't worry about what LCV is. I'm going to mention it and tell it to you in just a minute. While LCV is less than or equal to 10, in fact, I'm going to set it to 1 here. And I'm going to say console.writeLine LCV dot toString. All right, that's all I'm going to do. All right, you may or may not be able to figure out what this is going to do, but I'm going to show it to you anyway. So I'm going to run the program here. And it prints out, whoa, I'm in an infinite loop. It's printing 1 and 1 and 1 and 1 and 1 and 1 and 1. It's because I have to add 1 to my LCV. Now with that in here, and again, I'm going to come back and explain each line in blue here in just a second. Now, there's my numbers 1 to 10. Hopefully you can see that. And if you can't, you'd have to write it out yourself. So what are we doing right here? All right, LCV stands for loop control variable. It's what I like to call it. So what I'm doing, come on, Jeffrey. So what I'm doing in this line right here is I'm initializing the loop control variable. That's what I'm doing there. I am initializing the loop control variable. So what am I doing here? I am testing the value of the loop control variable. And what am I doing right here? I am changing the value of the loop control variable. And if you can understand this, you understand while loops. So what do? We're LCV, this loop control variable, is going to control how many times we run through this loop. How many times do we want something to happen? All right. Okay. So we want this to happen. The stuff that goes within the curly braces, we want it to happen 10 times. So we want to write that number out, and then we want to add 1 to it. So play computer here. The computer comes in and says we got a new variable here called LCV. It's got a value of 1. Is 1 less than or equal to 10? Yes, it is. So it writes out 1. Then it adds 1 to LCV, making it 2. It comes back up and it says, is 2 less than or equal to 10? Yes, it is. So it writes out 2. It adds 1, making it 3. Then it comes back up and it says, is 3 less than or equal to 10, etc. When it goes through there the 10th time, it says, is 10 less than or equal to 10? It is. So it prints it out, adds 1 to it, making it 11. 11 is not less than or equal to 10. So it immediately drops out of the loop. All right. Now, this is called a pretest loop. What does that mean? It's easier to show you. I'm going to make that 11. And I'm going to save it and run the program. And I get, that would be no output. Why? Because 11 is not less than or equal to 10. So if the condition is false initially, like when I just made that 11, you never go in and run the loop. Now, why is this nicer than just doing one console write line? In this case, not a lot, but notice if I make that 100 and I save it, now I've got all the numbers from 1 to 100. And I could make it 1,000 or 10,000 or 1,000,000 or whatever. All right. But to me, this is the easiest way to explain this. So we're working here with a while loop. All right. Now, I'm going to go down and write the next kind of loop. And the next one I'm going to talk about is the for loop. It also is a pretest loop. And it's also known as a counting loop. All right. So I'm going to write here for int LCV equals 1, LCV less than or equal to 10 plus LCV. And then I'm going to put this body, just that line inside of here. Now, it's giving me an error because I've defined LCV here, and then I redefined it here. So let's call this LCV2. All right. What you can see on your screen right here is a while loop that is 1, 2, 3, 4, 5, 6 lines long. 7, I guess, if you include the comment, but 6 lines of code where 2 of those lines are curly braces. When we rewrote it, it went down from 6 lines to 4 lines. Why? Because in a for loop, you initialize your loop control variable, you test your loop control variable, and you change your loop control variable, all of them on the same line. So you're doing the same thing. What you definitely need to know in here is how many times you want to go through the loop. Okay, so what you'll see if I run this, okay, let's put up some blank lines in here. So I'm going to say console.writeLine, oops, and I'm going to put in a \n, \n. So I should have the numbers 1 to 10, 3 blank lines, and then the numbers 1 to 10 again, if this works. Whoop, what happened? Didn't look like it worked. So equals 1. Oh, that should be LCV2. Sorry. That's why it was breaking. All right. So again, kind of hard to see, but there's the numbers 1 to 10, 3 blank lines, and the numbers 1 to 10. All right. These are 2 ways of writing the same thing. Now, I mentioned this is also a pretest loop. If I set that to 11 to start with, 11 is not less than or equal to 10. So rather than having the numbers 1 to 10 print out twice, it only prints out once. All right. And then let's look at the last type of loop. I'm going to go steal the while loop here. Okay. So let me hit enter a couple times. And this is what's called a do while loop. All right. It is not a pretest loop. It is what's called a post-test loop. So again, this will now be int LCV3, and this will be a 3, but you grab that line and you replace it with the word do. Oops, try that again. All right, almost done here. And here you put in the while, and it must have a semicolon at the end. All right, so that'll need to be a 3 here too. If this works, I will now have 1 to 10, 3 blank lines, 1 to 10, 3 blank lines, and 1 to 10, if I did it right. So File, Save All, run it. There's one set of numbers. There's another set, and something is hosed, so I did something wrong, so let's fix it. LCV3, 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 LCV2, 2 and 2 and 2, LCV, LCV, and LCV. So what did I do wrong here? Int LCV3 equals that. Do, let's hold that right line, LCV3. Okay, so let's see now if I get 3 sets of numbers. Okay, it's only showing me 2, but we'll fix it in a minute. So we're getting a set there and we're getting a set there. All right, so Y, right line, there's my read line. Let's just get rid of, for now, I'm going to comment out these right lines here and here. All right. There's the numbers 1 to 10, there's the numbers 1 to 10, but it's stopping right there. See if we can figure out why. Do, set it to 3. Do this while LCV3 is less than or equal to 10. So write out, right line LCV3. I want to make sure this is actually working, so I'm going to just put in here, hello, plus that. All right, see if that's the one that's not printing anything out. No, that's printing, and that one's printing. All right, so that one is printing. One of these here is not printing. So we'll do it like this. We're going to say while loop plus that. Here we're going to say for loop plus that. And here we're going to say do while loop plus that. All right, see if we can figure this out. So the while is printing and the do while is printing, but for whatever reason, the for loop isn't printing. So let's see if we can figure out why that is the case. Oh, because I changed that to an 11. So now let's see if I've got them all in there. All right. So while loop, 1 to 10, for loop, 1 to 10, do while loop, 1 to 10. All right, there's the whole thing. So it is working. All right. Now, let's go over the do while because I went over the other ones. And I'm going to uncomment these and just put 2 blank lines. That should be enough. So now when I run this, there we go. Okay, that looks pretty good. All right. I went over the while loop where again, we initialized, we tested, and we changed it. We went over the for loop where you initialize, you test it, and you change it. Now we're doing the do while loop. And no, we're not testing it there. We're testing it down here. So you test it at the bottom of the loop. All right. Why is that important? With this, since you're not testing it till the bottom of the loop, even if I make this 111, even if I do that, it always goes through the body of the loop once. So notice I now get do while 111. All right. Now, some people say, because I've given this lecture before and people have said to me, okay, I even sort of get this. That said, okay, I sort of get it, but that said, why would you ever use this? What a lot of developers do, not all of them, but what a lot of developers do is when they are writing their code and they've got error code, code that should run if there is an error, they want to force that error code to run to make sure that it's okay. So they take what had been in a while loop and they put it into a do while loop, which will, since it's a post test, it'll force that error code to run once. Then once they're sure that it's running correctly, they go back and they make it a while loop again. All right. You'll find that other than that, most of the time, people don't use do while loops. In fact, I've heard it said that to many people, using a do while loop is kind of counterintuitive to do that. All right. I don't know if that's true or not true. Okay. So let me jump back into the book then. So I'm going to do a file, save all. Again, I'm going to take this whole thing that we've got here that we've been working on, and I'm going to set that out to GitHub at the end of class today. All right. Go back to the book. So how to code while and do while loops. They will say in here, maybe they won't use the same verbiage as mine, but they will say that with a while loop, that it's evaluated at the beginning of the loop, and with a do while, it's at the end. All right. I call them pre-test and post-test. Okay. So they show it's very similar to the one I just wrote you. All right. With both the while and the do while. Okay. And then they go through and they talk about a for loop. And again, for when you initialize your loop control variable, when you test it, and when you increment it. You don't have to increment it. If you're counting backwards, let's say I was doing a program that was simulating a rocket going off, I could start at 10 and go down to 0 if I wanted to do that. All right, let's grab it, go into these and look at break and continue so you can hopefully understand those. I'm going to go back to the program that we were just in. Whoops. I'm going to go back to the program that we were just in. So I'm going to have to change my share. Back to Visual Studio. Okay. I'm going to comment out everything we had in here for the for loop and the do while. I'm going to comment those out for now. And I'm going to keep the code we had in there for the while loop. In fact, what I'll do is I'm going to grab this, copy it, and then I'm going to comment it out. And I'm going to put it down here. Paste it back in again. All right. So you already know how this works. We talked about it already. Let's assume here that once we get to the number 7, we want to break out of the loop. We don't want to be in here anymore. So I can come through here and I can type in this. I can say if LCV equals 7, break. Just like that. Now, what should happen here is it should print out the number 1. It's not 7, so it should add 1 to it. Come up here, print out the number 2. It's not 7, add 1 to it. Come over here, print out the number 3, etc. Then after 6, it comes down here, it adds 1. It is 7. 7 is less than or equal to 10, but since it's 7, it should break. So the output here should be, so the output should be 1, 2, 3, 4, 5, 6, each on a different line, of course. All right. So let's see if indeed that's the case. All right. It said 7, but wait a minute. We said if it said 7, break. Why? Because it was already 7 here. So let's take this line and let's move this down and only print it out if it's not 7. So now let's save it and run it again. And we get the numbers from 1 through 6. All right. So break does just that. It breaks you out of a loop. Now, continue is a different animal. So I'm going to change this from break to continue. That break, if you remember, we saw that earlier. All right, what do I mean? What I mean is when we were looking at the switch statement, we used the break to get out of there. So with continue, if it's equal to 7, it should skip all this stuff and go back up to the top. All right. Now we could have a problem. This may be an infinite loop because it's always going to be 7. So I might get an infinite loop here. I might have to change the order in which I have these lines of code. Let's look. See, it's stuck right now, but it did only go through 6. It's stuck right now on 7. Okay. So what I want to do is, let's see. I'm going to take these 2 lines. Let's see, which one do I want? I'll do this one. And I'll print out the value. Okay. So we will come down, it'll be 6. We'll come up there. It will print out 7. And then it'll hit continue. How are we going to do this? Let's do this. Continue. What we want to print out here is 1, 2, 3, 4, 5, 6, 8, 9, 10. We want it to skip 7. All right. It still has to do the plus plus LCV. It has to do that. Otherwise, we're going to be in an infinite loop. Let me take this line of code and put it down here. And then let's take a look at what we've got. We'll come right back to it. So notice it didn't print out 7. It didn't print out 1 either. We'll have to fix that. But all right. 2, 3, 4, 5, 6, 8, 9, 10, 11. Well, that means my checks are bad. All right. So it's 1. We'll set it to 0 to begin with because we're adding 1 to it right away. And 1 will not be equal to 7, so it'll skip that and it'll print out 1. Eventually, it'll be 6. It'll print that out. It'll add 1 to it. And it will say, is that equal to 7? It is. So it'll continue. It will not print out while loop 7. All right. So this should give us the output we want. 1, 2, 3, 4, 5, 6, 8, 9. All right. Now it's got 10 and 11. So I should just change that from less than or equal to less than 10. All right. And then we should get the output 1, 2, 3, 4, 5, 6, 8, 9, 10. Let's double check. 1, 2, 3, 4, 5, 6, 8, 9, 10. All right. That was a little longer than I planned on it being, but I wanted you to be able to see the break statement and the continue statement. All right. Now you may look at this and you may say, you know, I like the way they explain. I like the way they explain it better in the book. Well, that's fine. That's why I want you to read the book. And I should mention this in front of everybody. You got an email from me yesterday. And Mr. Glynn told me no one has come in yet to pick up their book. The books are in. You're not going to learn this language by just watching my lectures. The book is a terrific, terrific resource. All right. So please, if you have not gone into the Rankin-Wentzville campus, into the Larry Elms Training Center, where Mr. Lynn's office is, go in there and get your book. All right. So they've got their own examples where they use break and where they use continue. I probably should have looked at their examples. It might have helped mine. All right. Debugging techniques for loops. All right. We have already talked about breakpoints, so I'm not going to go through that anymore. We're going to have a whole chapter when we get to chapter 11 that's on debugging. So I'm just going to hold off on that. Now, the last thing that they give in here is this future value presentation. And rather than doing the future value presentation, what I'm going to do is I'm going to go back over the program that I started yesterday, that being that payroll program. All right. So it is 10:01. Let's take another break, please, until 10:12, and I'll come back and I'm going to rewrite or add to that payroll application. So I'll see you in about 10 minutes, please. All right, it is 10:12, so I'm going to start back up. I did create a a repository called Chapter 5 that's public. And if you go out there, what you're going to find is, if you have to dig through it a little bit, it's that console app. And if I go down to program.cs, it has all of the examples that I've gone through. You can see that many of them are commented out. And it's a couple hundred lines plus, right? 254 lines, but it's all in there. So if you have an interest in looking at that, you can go down and copy that. All right. That chapter 5 repo. Okay. Now, as far as what's left in the chapter here, they talked about that. Um, they talk here about the future value app, and I said I'm not going to go over that right now. It's not a bad program. I think there's better ways that we can spend our time. So you can look at that. It's just 3 or 4 pages, and that finishes the chapter. So I want to do 2 more things, and hopefully I'll have you out of here by 11 o'clock. The first thing that I'm going to want to do is I want to make some changes to the payroll program that I gave you the other day. In order to do that, all right, I'm going to change my share. Not there. Doggone it, Jeffrey. So I've got to come in and change my share. So I'm going to do that first. And I'm going to change my share so that I'm sharing back on Visual Studio. And you should see, hopefully you see now, my payroll program. So I want to go over that. And then I'm actually going to show you the pretest that I am going to email to you immediately after class ends, but you will have about an hour today to work on it and an hour and a half tomorrow to work on it. There's only 2 problems. They're both GUIs. Okay, so I'm going to do a couple things in here. So first of all, I'm going to write, whoops, Control A. Try that again. All right. I want to be able to change my interface a little bit. So I am going to do this. I'm going to bring this down over here a little bit. You'll see why in a minute, okay? And what I want in here is every time we add a payroll, I want to put in here the number of payrolls we have, the total payroll, the average payroll, the highest payroll, the lowest payroll, and the average payroll. All right. So in other words, I'm going to pull these over to here, and I'm going to copy this that now says gross, but I'm going to put it in here a bunch of times. So this right here is going to be the number of payrolls. This is going to be the total payroll right there. This will be the average payroll. This will be the highest payroll out of all of them. And this will be the lowest payroll out of all of them. It'll allow me to use some ifs and some other things. I'm going to try to line this up. So give me a second here to try to pretty it up just a bit. Now, you may have already figured this out, but I made all of these read-only on purpose. That's why I copied this one, because these will all be read-only fields. I'm going to change all these in just a second. But first, let me lock my interface back up. All right. And this one right here, this one will be total number of payrolls. So it'll be LBL, total number payrolls. And I'm going to change the text there to just total number payrolls, like that. Well, I guess I got to make it a little wider, so I'll fix that in a moment. All right. This will be the total payroll, period. Not the number, but the total payroll. So this will be LBL, total payroll. And I'll change this as well to total payroll. All right, that's just big enough. So let's do this. Let me unlock my interface, move all of these over a little bit, grab these, and widen these out. All right. And then lock my interface, whoops, back up again. All right. So this was total number, still wasn't big enough. Oh, I guess I thought I made it bigger, but then I must have okay, try it again. Now it's locked. So total number of payrolls, total payroll. This will be the average pay. So this be LBL. I'm going to call this, I'll tell you what, instead of total number of payrolls, I'm going to call that total number gross pays. All right, and I'm going to change this to total number of gross pays. Hopefully it's big enough. There, good. This will be the total gross pay. All right. And this will be LBL, total gross pay. This will be the average gross pay. So it'll be LBL, average gross pay. And I will change this to average gross pay. All right, this will be highest gross pay. And I'll have to change the name to LBL, highest gross pay. And this will be the lowest gross pay. So I will change the name to LBL, lowest gross pay. And I will change the text on there to lowest gross pay. All right, now I just have to change the names of these. So this will become, in fact, I'll grab them from here. So this will be TXT, total number of gross pays. This will be TXT, total gross pay. This will be TXT, average gross pay. This will be TXT, highest gross pay. And finally, the last one will be TXT, lowest gross pay. All right, so I've got all that done. I want to do one thing because I'm just anal about this stuff. I don't like the way this looks. I'm going to pull it down a little bit. There. Lock that back into place. Now this should be set. The only other thing I want to set in here, even though these are read-only fields, I want to redo my tab order to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, I don't have to do that. The program would probably work just fine without it, but I want it anyway. So I'm going to go down to view tab order. And that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, and then do another view tab order. So that's all set. Now, none of these buttons are going to do a flipping thing right now. Nothing. Because I haven't asked them to yet. But my interface should still run. Oops, I got to change the program. Sorry. So let me change this to payroll GUI. So I can come in here and I can put in Jeff Scott worked 50 hours and made 20 bucks an hour and do all that stuff. All right, that still works. But I want to change a couple things here. First of all, I want this to become a 1 now. That should be 1,000. That should be 1,000. So should that. So should that. But if I do it again with a 60, then that'll be up to 2. That'll be 2,200. That'll be 1,100. That'll be 1,200. And that'll stay at 1,000. If I do it again, now it'll be 3. It'll be the addition of all those 3. The average of those 3, the highest will still be 1,200 and the lowest will now be 400. But I want to do one more thing. So that's one thing I want to do. The other thing I want to do is I want to give, if a person works more than 40 hours, I want to give them overtime, which I'll just set as time and a half. So I'm going to put all that stuff in there right now. So let me go to the calculate. And the first thing I want to do is I want to be able to add a few things in here, such as, well, I want a decimal. In fact, let's do it for an int. That'll be the total number gross pays. All right, I want that. Okay, and I'll just do it. I won't even initialize it. In fact, I'm going to take all these variables because these are going to be every time I'm going to be changing them, and I'm going to put them all out here. So int total number of gross pays, and I'll initialize that to 0. I'm going to have another one, int total, that'll be a decimal, total gross pay, and I'm going to set that equal to 0.0m. Another decimal that I'm going to call AVG. In fact, we can call it the whole thing. Average gross pay that I'm going to set equal to 0.0m. Decimal. What did I call these in here? I just want to use the same names. So this was total number gross pays, total gross pay, total number gross pay, total gross pay, average gross pay, average gross pay, and highest gross pay and lowest gross pay. Okay, that's fine. All right, so I've got all that stuff as far as I can tell, at least that's all set. And I also want to go and I want to add 2 constants. So these will be my class level variables. So they're not local. And I want to add also my program constants. I'm going to make a couple, 2 or 3 of them. So my program constants. The first one will be the maximum numbers of hours you can work without getting overtime. So I'm going to say decimal, make it a const, I'm sorry, const decimal max non-OT, and I'm going to set that equal to 40.0 M. I'm going to have another one that it's going to be a decimal, and it's going to be called OT rate, and I'm going to set it equal to 1.5 M. So in other words, if you're working overtime, you should get time and a half, is what that's saying. All right, so these are all my variables and constants that I have to account for. So every time I come through here and I do this, okay, what do I want to do? Well, I just did another payroll, right? Or another pay. So I want to add 1 to my total number of gross pays. So I want to increment that. So a plus that. Okay, so I've added 1. And after I add it, I can do a txt, and I can say total number of gross pays dot text equals total number gross pays dot toString. I don't have to do any special formatting on it because it's an integer. So that is handled this one. Now I've got to do my total gross pay. All right. So I've got to say here, total gross pay plus equals the gross pay that I just figured out, which was gross. And then I want that to print as well. So txt total gross pays, not total number, sorry, total gross pay dot text equals total gross pay dot toString. I do want that formatted with currency. So that's the second one. So increment this, set associated text box. All right. Then I want to add current gross pay to total gross pay and set the associated text box. So now these two are done. Then I've got to do the average. So I've got to calculate the average gross pay. And again, I want to set the associated text box. How do I do that? Well, the average gross pay is equal to the total gross pay divided by the total number of gross pays. And then the txt average gross pay dot text is equal to the average gross pay dot toString. And again, we'll want that to be currency. All right, so now I've got 3 of my 5 done. So I need the highest and I need the lowest. All right. Now I'm going to do something that may sound a little goofy, but let me do it and then explain it to you. I'm going to set my highest gross pay to negative 1,000 M. And I'm going to set my lowest gross pay. I'm going to set my lowest gross pay to 1, 2, 3, 4, 5, 6, 7, 8 M. By doing this, my highest gross pay, by making that negative to start, as soon as I do a positive gross pay, it'll replace whatever was in there. I could keep that at 0 and it would work fine, but I wouldn't want my lowest to be 0. So I'm making it a real high number. And I'm doing that on both of these. I'm making the highest a real low number and the lowest a real high number. So the first time I go in and I do a brand new gross pay, it'll replace what had been in there. That's what I'm telling you. All right, so let's do these, the highest and the lowest. So here I want to calculate the highest gross pay. And I'm just not using the variable names here. I'm just letting you see exactly what's going on. And again, I want to set the associated text box. Now I can say if the current gross pay that we just did, which was gross pay, if, not average, if the gross is greater than the highest gross pay, which again we called highest gross pay. Well, if that's the case, we have a new high. So then the highest gross pay is now equal to the gross. And after we do that, we can say txt highest gross pay dot text equals the highest gross pay dot toString with a C. Now I'm going to just copy all of this and change highest to lowest. txt. Oh, I spelled it wrong. I've got a little L in there for some reason, so let's fix that. I think it's right now. All right, which means it'll give me an error in here now, sooner or later. So, yeah, it changed it. So I should now have everything set. Okay. Now, I'm going to come back and do the overtime, etc. in just a minute, but let's see if what I've done so far works. All right, so I'm going to come in here and I'm going to put in 3 payrolls. Okay, so when I test this, I'm going to test with 3 different payrolls. Let me put a comment in here. Whoops. Slash. So let's put in here, I don't care about the names, but we'll say person 1. All right, and then we'll say hours are going to be 20. Rate is going to be 20. And the gross should be 400. We'll put in 3 people. Then we'll put in person 2. The hours are going to be 30. The rate is going to be 20. And the gross should be 600. Then we'll do person 3. And we'll say the hours will be 10. The rate will be 20. And the gross should be 200. All right. Then when we get done with all that, the total number of payrolls or a total number of gross pays should be 3. The total gross pay should be 1,200. All right. The average gross pay should be 400. The highest gross pay should be 600. And the lowest gross pay should be 200. Now, looking at that, hopefully with each and every one of you in here, hopefully that all makes sense. All right, so I'm going to grab this. And I don't need to grab it. I can go back. I'm going to run the program right now. So I'm going to do a file, save all, and I'm going to run it. But when I run it, I'm going to move this. So you can see this as I put this stuff in there. So I'm just going to put in here, Bob Smith, 20 hours, 20 hours. 400, 1, 400, 400, 400, 400. So far it works. Clear. All right, come back. Jane Doe. 30, 20, whoops, 20. All right. 600, so 400 and 600 is 1200. The average is 500, the highest 6, the lowest 4. That all works. Let's clear one more time and do Mary Jones, who worked 10 hours and makes $20 an hour. All right, so now let's look. 3, 1200, 400 is the average, 600 is the high, 200 is the low. So as of right now, everything works. All right. Again, the only thing we have to still do here is when I clear and I put in here Ken King. If Ken works 50 hours and makes 20 bucks an hour, Ken should not make $1,000. He should get overtime for the 10 hours that he worked over 40. So we're going to fix that right now. Then we'll run it again. All right. When we do that, we're going to put in 2 more people. So person 4, and we'll set the hours to 50. We'll set the rate to 10, and we'll set the gross. So 40 times 10 is 400, 10 times 15, so that should be 550 if I did it right. All right. And then finally with person 5, we'll do the same thing. We'll say that their hours were 60 and their rate, let's say, is 30. So they will make 40 times 30 will be 1200. And then 20 times 45 will be 900. I think it's 2100 if I did my math right. All right. So our total number of gross pays will then change to 5. This won't be 1200 anymore. It'll be 1200 plus all of this. All right, so 2100, 3100, 3300, 3850 if I did my math right. If I'm right, so 3850. All right, the average will be 3850 divided by 1, 2, 3, 4, 5. So what, 760, 700, about 770, something like that. The highest will be 2100. And the lowest will still be 200. We're going to put in the logic to do that right now. All right. So we've figured this out. So now when we go in here, the line that we want to change is this one. All right. So I'm going to change this and I'm going to remove that part that says decimal gross equals that. And I'm going to say that this is equal to 0M. Why? Now I'm going to come in here and I'm going to calculate the gross pay. So if hours is less than or equal to max non-OT, that means that they worked 0 to 40 hours, no overtime. So if that's the case, then their gross is their hours times their rate. All right. Else, try that again. Sorry. They do have overtime coming. So they worked greater than 40 hours, have overtime. All right. There's different ways that I can do what I'm going to do right now. All right. I'm going to do what I consider the easiest way for you to understand this. All right. So I'm going to create a local variable right here that I'm going to say, well, let me do it without it. So I'm going to say here, gross equals. What I want to do is I want to take the hours, the max non-OT hours, that's 40, times their rate. That's their regular pay. That's their 40-hour pay. But then I want to add to that. So I'll put it on a new line. So I want to add to that the hours that they worked. Let me put two parens in here. The, the hours that they worked minus 40. All right. And that'll give me, so if they work 50 hours, that'll be 10 times the rate times the overtime rate. All right, I may be, yeah, okay, that should be right. Now, when I come through here and I set the gross pay, wherever I did that, TXT, let's look. TXT gross pay, et cetera, et cetera. All right, I might have not done that before, so let's see, there's total gross, total number, let's just put it in here. So TXT gross equals gross dot toString, and it'll be currency. That's dot text. All right, now I'm going to save it, and I'm going to come back to all these values I had here. I'm going to run it. I'm going to put my window over here so you can see the entire program run. All right. So again, well, I'm just making these up. Jane Smith, and Jane worked 20 hours, and Jane makes $20. Oops, makes $20 an hour. So that's 401, and they're all 400 because there's only been one employee. I clear, Mark Jones, and that'll be 30 and 20. Looks like it's still working. Clear again. 80 green, 10, 20. That's all the ones I had before, so that all looks like it's working. All right, let's clear again and put in two more people. Mike Manson, who worked 50 hours a week and makes $10 an hour. So this is the first test. This should be 550 if I did it right. 550. All right. Still doesn't have a new high, but now this is skewed a little bit. So finally, the last one, and that will be Gary Johnson, who worked 60 hours a week at $30 an hour. I think 2,100 that I put in there is right. It is. So 3,850, 770, 2,100, and 200. All right. So we are done. Let's quickly, and I mean quickly, go over this. All right. So I'm going to exit here and say yes. All right. I think it's always a good idea that you have some test data ahead of time. Do you have to do that? Of course not. You don't have to do anything. But these are going to be my test cases. Whoops. So that's my test data. And then these will be my expected results. Again, of course, you don't have to do this, but especially those of you who have been struggling in here, not a bad thing to do to make sure your logic was correct. All right. So we came in here and what did we change? We added two program constants. So this is max hours worked with no overtime. This is the overtime rate. Now, one reason that I made this 40 and I made it a constant and I made this 1.5 and I made it a constant, over time, it's possible things could change. What do I mean? Well, it's possible over time, they might say that the most numbers, they might force people to work 50 hours before they get overtime, or they might knock it down to 35. They might change the overtime rate to 2, etc. So this program is open for a lot of change if need be. All right. So that's those two that I added. Then we have this, and this is the total number of gross pays calculated. Then this is the total of all gross pays. Then this is the average gross pay. This will be the highest gross pay. That's pretty obvious. And this will be the lowest gross pay. Spell that wrong. All right. So here, the hours and the rate, these two things are things that I'm just entering. So the things that I'm entering are what? When we look over here, there are these four things. I don't have to do anything special with a name. Now, what you're going to learn fairly soon is, well, what if it's blank? We'll talk about that probably next week. All right. So now we're saying text gross is equal to nothing. There's where I was printing that, so I don't need that anymore. So I calculate the gross pay. So the first check in here is first check for possible OT worked. All right. So actually I'm checking for no OT. First check for no OT worked. So if that's the case, it's just straight time. It's hours times rate. But if this is not true, then they worked some overtime. Now we could have separated that and broke that down and made our own variables out of it, etc. I'm just going to leave it the way it is. It works. So this is the straight time. This is our 40 hours. This is our 40 hours times our pay rate. And we're adding to that the hours we worked over 40 times our rate times 1.5. So that's our overtime. So in other words, this is our straight time. So that's 40 hours. And this is our overtime. So that's greater than 40 hours. Then we just print it out. All right. So again, I've been saying that all the time. It's not a greatest comment, but set the associated text box. So that's going to set this one. Then we have to figure out these 5. And again, these 1, 2, 3, 4, 5, 6 out of 10 text boxes are read only, because we're letting the program itself figure out the value that goes in there. We're not inputting those values. So we add 1 to our total number of gross pays, and then we print out that whatever that number is. Then we add the current gross to our total gross pay and put that in the associated text box. Then we figure out the average. The average is what we just figured out, total gross pay, and we're dividing that by total number of gross pays. And then we put that in the associated text box. Finally, we have to calculate or check for the highest gross. If the current gross pay is higher than what we had in there initially, and remember, initially we had in there negative 1,000. So as long as they did something that was positive, it should be a new high. All right, when we get down to this. So that current gross becomes our high. Then we check it every time. And then we also set the associated text box. Then we do the exact same thing, but instead of checking if it's greater than the highest, we see if it's less than the lowest. And we set the associated text box. That's it. So I am going to take this and I'm going to put that out also. All right, I'm going to put that out as well. So I'm going to do a file, save all. I'm going to do it all in front of you, or try to do as much as I can in front of you. So file, save all. I'm going to close this. All right, I'm going to come back in and I know you probably can't see anything now, but I'm going to come back to my payroll program. So let me change my share. I'm going to have to change it a couple times. All right. So let me change my share. And I'm going to change it to my get window here. Not that one. That must be it. Let's see. All right. Hopefully you can see my get window right here. So I'm going to do the same kind of stuff I've been telling you to do. I don't need to do a get init. So I'm going to do a get add dot. And that adds, if I want to see if there's anything that's been added, I can type in get status. And there's a bunch of stuff in there that's been changed. All right. So a get add dot, then a get commit -m with chapters 4 through 5 changes added. Hit enter and it does all that magical stuff. Clear the screen and I'm going to say get push -u origin master. That's good that it did all that stuff. Then last thing I'm going to do here is I'm going to change my share one last time here. And I'm going to change it to the internet. All right, and out on the internet, I'm here on GitHub. All right, and I've got to find my Muroc payroll. There it is. And when I bring it up, all right, chapter 4 or 5 changes 43 seconds ago. All right, so you've now got all of that stuff in there. All right, so the last thing that I want to do with you right now, all right, the last thing, did I bring this up or did I not bring this up? I'll have to bring it up. Hold on a second. Open, I got to find the pretest. There it is. Good deal. So what I'm about to show you right now, I am going to email to you as soon as we end our lecture today. All right. This will be the pretest for chapters 1 through 5. There are 2 problems. For this pretest, you will create 2 different GUI Windows Forms project. Create both under the same solution, ideally under that folder that you've been calling pretest. For each project, set the tab order, set the accept button, set the cancel button, and set the start position. Change the name of your form and the form text, just so you know when you take your test next week. To force you to do A and B that I have right there, they're going to be worth points. They will be worth points. All right. Create a program prologue at the beginning of the code. What is that? It's a comment at the beginning. For any numeric values inputted, verify they're not empty and they're not numeric, not numeric or within range. So you would say, well, we didn't really do this. Give it a try. This is what I want you to create. Okay? You can put in a Fahrenheit temperature and click this, and it'll give you the Celsius equivalent in here. Or you can type a Celsius temperature in here, click this, and it'll give you the Fahrenheit temperature in there. Clear will clear both these text boxes and set the focus. Exit will exit. So convert F to C, you're going to have to check here to make sure this isn't empty. And you're going to have to make sure it's numeric. And I'll give you a hint on that one. Back in chapter 4, we looked at try parse and we looked at parse. Take a look at those. All right. And there are some other requirements that are in here. All right. So you will set constants for minimum Fahrenheit and maximum Fahrenheit, for minimum Celsius and maximum Celsius. Now it says try to modularize your program. We haven't talked about modularizing yet. So what I'm going to do when I write this for you is I'm first going to write it the way you all probably will. Then I'm going to modularize it so you can see the difference. All right. So I've got your requirements are here on page 2, and there's pictures of what it should look like on 3, 4, 5, and 6. All right. Then the next one, in baseball, a player's average is calculated by dividing the number of hits they have by the number of at-bats. For instance, if a player has 4 hits and 10 at-bats, their average is 400. All right. Write a GUI program that lets the user input hits and at-bats. From there, what you're going to have to do, show you where it works. Come on, there. So if I put 10 at-bats and 5 hits, they have a 500 average. All right, keep track of the highest batting average, the lowest batting average, and the total number of averages. You don't have to do the average. You can if you want to. All right. So this is very, very, very similar to the payroll program that we just did. So again, I am going to email this to you as soon as I finish today. So it'll be in a matter of moments. In fact, just so you can see it, I'm going to do it right now. So let me come in here. All right, and let me do a new message. Scott, and then all of you. Oops, try that again. I don't want those there. I don't like sharing people's stuff because sometimes people don't like their email addresses shared, so I will put them in there. Then I will come up here, and this will be chapters 1 through 5 pretest. As noted in subject line above. Thanks. And I will attach to that, browse the computer, go to my desktop. Here is the pretest. I always like to double check. I don't ever want to send anything that would be inappropriate or wrong. So this should be the thing I just showed you. Well, that'll take too long because there's a lot of images in it, but it does say on here chapters 1 through 5 pretest. So it should be correct. All right, so I'm going to send it. So ideally, you now have all gotten those. All right. Okay, there it is. So you've all got the pretest. You have from now until tomorrow morning at 9:30. You can work on it at your leisure if you want to work on it. And then tomorrow morning at 9:30 a.m., all right, I will begin going over it. I am going to get on at 8 tomorrow, see if anybody has questions. I will remain on from 8 till 9:30, but you're just going to see a screen your screen is only going to have the pre-test on it. But if somebody has a question or whatever, they'll be able to get a hold of me. That's all I have. And again, thank you, Aiden, for being on here. If you have any questions, you can ask right now. Otherwise, you're free to drop off because that's all I had for today. Okay, I will talk to you all tomorrow then. Thanks a lot.